Nice launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
You're looking at a live view of Falcon 9 awaiting liftoff at 10:19 a.m. Pacific Time from Vandenberg Space Force Base, just a few hours north of our headquarters in Hawthorne, California. Thanks for tuning in for the Korea 425 mission, SpaceX's 88th mission of the year and 287th launch overall. My name is Ronnie Foreman, and I'm a commercial sales manager here at SpaceX. Today, we have 25 spacecraft on board for 6 customers, including Korea, Space BD, SITAEL, D-Orbit, York Space Systems, and PlanetIQ, all headed to a sun-synchronous low Earth orbit. At the request of some of our customers, we won't be showing any second stage views today. So given that, we are going to end our webcast after a booster landing around the 8.5-minute mark. But for those of you interested in learning more about today's payloads and deployments, please head over to our customers' websites for more information. Now at just over T-8 minutes, we are looking good for an on-time liftoff. The vehicle is healthy and the range is ready to support. And while it's a beautiful day in Vandenberg today, we are watching some ground-level winds ahead of liftoff, so we'll keep you posted as we move forward in our countdown. The 2-stage Falcon 9 vehicle on your screen stands 229 feet tall, or slightly taller than the Leaning Tower of Pisa in Italy. When it's fully fueled, it'll hold just over 1 million pounds of propellant that the vehicle will burn through in less than 3 minutes after liftoff. We began loading those propellants on both stages on the vehicle at around T-35 minutes. Now, starting from the top of the rocket, our 25 payloads today are safely enclosed inside of that 17-foot diameter payload fairing, which is the pointed structure on your screen. Made of carbon composite material, the fairing protects the satellites on their way to orbit. The fairing is then jettisoned approximately 3 minutes into flight. The fairing halves supporting today's
Engines
mission
are filling in for flight.
are flight proven, with one half flying for its 5th time and the other for its 6th. We will be attempting to recover those again today. Now, below the payload fairing, we have the second stage, which is the part of the rocket that will take our payloads to their destination orbit. The second stage will ignite its single Merlin vacuum engine, or MVAC for short, about 2.5 minutes into flight, and then will relight for a second and third time before we deploy the satellites. Just below the second stage, you can see the black interstage, which is part of the first stage booster. The carbon fiber interstage is a distinct black color because what you can see is unpainted thermal protection system, also called TPS. This system protects the composite material used to make the interstage. And at the bottom of stage 1, there are 9 Merlin engines that will get Falcon 9 off the ground and up to the thinner parts of the Earth's atmosphere. Shortly after liftoff, the first and second stages will separate from one another. Then the second stage will continue to orbit, while the first stage will start making its way back down to Earth. The first stage is designed to be reflown with minimal refurbishment between flights. Today's booster is flying for the 17th time. And we'll be attempting to land back on land not too far from our launch site, so you should have an especially good view today if you're joining us from Vandenberg. If we're successful in recovering the booster on screen, it will mark the 250th successful recovery of an orbital class rocket. And lastly, the large truss structure that you see there just to the right of Falcon 9 is the transporter erector, or TE for short. You may also hear the callouts on the net refer to that as the strongback. We use the TE both to roll the rocket out to the pad and raise it to its vertical launch position. The TE also routes the vehicle's fluids,
Tanks
power.
are pressing for strong back retract.
There we go. We're pressing up for strong back retract, which again routes the vehicle's fluids, power, and telemetry umbilicals from the ground systems to the rocket and satellites until Falcon 9 transitions to internal power. At liftoff, it will retract in order to clear the way for Falcon 9's ascent. Those clamp arms are just at the base of the fairing, and we should start to see them open up in about 20 seconds. There you can see the clamp arms are opening in preparation for the initial strong back retract. Now that those clamp arms are fully opened, and you've got that great view of the TE pulling away from Falcon 9. Right now, the first stage is connected to a launch mount at the base of the TE, but the structure is hinged, which is what allows that retraction that we just saw. At T-0, the ground hydraulic systems will pull the TE even further away from Falcon 9 as it lifts off and clears the launch pad. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. The first stage and second stage should finish loading propellant about a minute apart from each other. The first stage will finish up at T-3 minutes and the second stage at T-2. Now those white clouds that you see around the vehicle are formed as the chilled gas above the LOX tank vents overboard to maintain pressure as needed. When the gas comes out into the warmer California air,
Stage 1 LOX load complete.
there we heard that LOX load is complete on the first stage. And again, when that LOX comes out into the warmer California air, it condenses the water in the air and forms those beautiful clouds that you can see around Falcon 9. We are just over 30 seconds away from completion of LOX loading on stage 2. And at T-60 seconds, Falcon 9 will enter startup mode. This means that the rocket's autonomous internal flight computers will take over the launch countdown. Just inside of T-2 seconds, we will light the Merlin 1G engines for liftoff.
Stage 2 LOX load complete.
There we hear it, that stage 2 LOX load is complete. All 25 payloads continue to be healthy, and the Falcon 9 team is tracking no issues on board the rocket. That venting that you see, again, is totally normal as we vent the TE LOX line ahead of liftoff. And as a reminder, at the request of some of our customers, we won't be showing any views of our payloads today. Live coverage will end after first stage landing and a successful shutdown of our MVAC engine's first burn.
Falcon 9 is in startup.
There's confirmation that F9 is in startup mode. The internal flight computers have taken over the countdown, and stage 1 and stage 2 have begun pressurizing for launch.
LD is go for launch.
With that call out from our launch director, we know that we are go for launch. At just under T-40 seconds, all systems of Falcon 9 are ready for liftoff with our 25 rideshare payloads on board.
T-30 seconds. T-15 seconds. T-10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff. Go Korea 425. Go SpaceX.
Vehicles pitching downrange.
It is a beautiful day for launch, and Falcon 9 has successfully lifted off from Vandenberg Space Force Base with payloads for 6 of our rideshare customers on board: Korea, Space BD, SITAEL, D-Orbit, York Space Systems, and PlanetIQ. Now, during ascent, we tilt the engines. The technical term for this is gimbaling, and that turns the rocket horizontally in what we call a gravity turn. We're still going up, but now we are also heading horizontally away from the launch pad.
Max Q.
There's the call out from Max Q. So moments ago, we throttled engines down in preparation for Max Q.
Nominal.
Good call outs there that power and telemetry are nominal on board Falcon 9. Max Q is a critical moment during flight because the combined stresses caused by Falcon 9 accelerating through the atmosphere and the ambient static pressure are at their greatest. Now, the rocket typically needs to go around 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and reach orbit, which is why we perform that gravity turn. You can track our progress to orbit by keeping an eye on the Stage 1 telemetry in the bottom corner of your screen. Now we have 6 events coming up in quick succession: MECO, Stage SEP, S1 Flip, SES1, Boost Back Burn, Start, and fairing separation. During main engine cutoff, we'll shut down the 9 Merlin 1D engines, which is followed by stage separation.
Nominal trajectory.
Nominal trajectory on board Falcon 9. Once separated from the second stage, the booster will flip its orientation and begin heading back to Earth with a short boost back burn, while simultaneously, the second stage MVAC engine will ignite for the first time, followed quickly by fairing separation.
MECO. Stage separation confirmed.
Confirmation of MECO and stage SEP.
And back ignition.
Good call-outs that we've had
Stage 1
SES1
boost back startup.
and boost back burn startup.
Fairing separation confirmed.
So we've heard those call-outs for those 6 events that happened back-to-back and got great views of several of them. That was MECO, Stage SEP, S1 Flip, SES1, Boost Back Burn Start, and fairing separation. We will be attempting to retrieve those fairing halves again today once they fall back to Earth, using our recovery vessel, Go Beyond. Next up, we're listening to hear that we've completed our boost back burn.
Stage 1 boost back shutdown.
Right on schedule. We are just about T plus 3 minutes and 28 seconds into today's mission, and the next critical milestone we're tracking is T plus 6 minutes and 42 seconds, when we expect to have some great views of the first stage's entry burn. For the entry burn, we relight 3 of the M1D
Both vehicles
engines.
remain on a nominal trajectory.
There we hear that Falcon 9 remains on a nominal trajectory. For the entry burn, first we will relight the center E9 engine, followed shortly after by E1 and E5, which slows down the vehicle as it passes back into the Earth's atmosphere. Great views on your screen right now of Stage 1 and those grid fins as the booster heads back to Earth. We relight those engines to slow down and reduce re-entry forces, which ultimately helps us recover and reuse the first stage. During the entry burn, Falcon 9 is decelerating by firing those Merlin engines, but we're still moving really fast. This causes the vehicle to fly through Merlin's exhaust gases, also called the rocket's plume. And this deposits a layer of soot on the vehicle's surface, which is why our flight-proven vehicles tend to look so toasty. That soot comes from the carbon-based fuel that Falcon 9 uses. Now, as a quick reminder, at the request of some of our customers, we won't be showing any views of our payloads today. Live coverage will end after the first stage landing and successful shutdown of MVAC's first burn. Just about a minute and a half until we expect to hear the call out that that entry burn has begun. Those grid fins on your screen are the primary mechanical mechanism that we use to steer the booster on its way back to Earth. Interestingly, even though they look quite small next to Falcon 9, they are about 4 by 5 feet, so about as large as a coffee table. Of course, we reuse our boosters and fairings here at SpaceX because reusability is a key to lowering the cost of spaceflight, which enables more investments in critical scientific research. Again, the Falcon 9 first stage supporting today's mission is about to perform this entry burn for the 17th time. Great views of the coast of California beginning to come onto your screen now.
Stage 1 entry burn.
Confirmation of entry burn startup. On your screen right now, you have two views of our first stage, one from our onboard camera on the left, and on the right-hand side, you can watch that landing as we come back toward landing zone 4 at Vandenberg Space Force Base.
Stage 1 entry burn shutdown.
Confirmation of entry burn end.
Saved.
The Merlins on board the first stage are optimized for sea level. These achieve about 190,000 pounds of thrust during both ascent and descent, while the MVAC engine is optimized to operate in space, producing 220,500 pounds of thrust in vacuum. Coming up next, we'll shut down our MVAC engine on the second stage, followed quickly by our landing burn on the first stage. And as a reminder, we are targeting a land landing at landing zone 4 at Vandenberg Space Force Base today, which is just west of our launch pad.
Stage 1 transonic.
Stage 2 FTS has saved.
Beautiful views
Stage 1
there,
landing burn.
and confirmation that we have begun our landing burn. We're now waiting for Falcon to land back at landing zone 4.
Stage 1 landing leg deploy.
And there you have it.
Stage
That
1
marks
landing confirmed.
SpaceX's 250th recovery of an orbital-class rocket, including first-stage landings for Falcon 9 and Falcon Heavy. While the mission isn't over just yet, as a reminder, we won't be showing any second-stage views today, and therefore we're going to end our coverage here. All of us at SpaceX want to give a big thank you to our customers, including Korea, Space BD, SITAEL, D-Orbit, York Space Systems, and PlanetIQ for entrusting us with today's mission. For those of you interested in learning more about today's payloads and deployments, please head over to our customers' websites for more information. We also want to give a shout out to the Range and Federal Aviation Administration for supporting today's launch. Thanks to all our viewers for tuning in and for your continued support. We'll see you again soon.